One of the things you'll encounter in Verilog is two different equal signs. One is a blocking equal sign. These occur within always blocks. One is a blocking equal sign that's just a regular equal sign. The other is this, arrow kind of equal sign. This is a non-blocking assignment. Now, it turns out the way that you know how to use these is that for sequential circuits that use flip-flops, you would use the non-blocking description, and for combinational circuits, you would use blocking. So let's go over it for sequential. All right, so what I have set up here is two different examples. One is a sequence of flip-flops where one input is connected to the first flip-flop, then it's connected to the second and connected to the third. It's the same circuit in both cases. And then you have the always block that gets implemented on the positive edge of the clock, and this is the execution trace for both blocking side and the non-blocking side. So before we cover that, let's go over the correct operation. It turns out that non-blocking is the correct one. So let's see what happens here. What's going to happen is this is a shift register, so this data 1010 should be shifted in serially from the left-hand side moving over to the side here. So let's watch that happen. On a clock edge, you see that all the things get updated at once. That's what non-blocking means, that you don't have to have Q1 assigned to D before Q2 gets assigned. All these get assigned at once. And so that first one gets clocked into the shift register. So we do it again. This time the 0 gets clocked in and the 1 moves over, just like you would expect on a shift register. And then one more time, the 1 gets pushed in. Now we're at 101, and the last example would be pushing in the 0, and everything moves over to the right to 010. So that's the correct operation, and the way that works is all these get assigned at the same time. So if you had described this with blocking statements with the equal sign, let's see what would happen. So we're going to go back. We won't get the same data, but let's look at this sequence of data. So 1, 1, 0, 1. All right, so what happens with the blocking statement is when you operate this, we'll go through it. There's the positive edge of the clock, and this happens first, blocking this one before it happens. So Q1 equal to D, and then Q2 is equal to Q1, and then Q3 is equal to Q2. So because Q1 is equal to D, that Q1 gets assigned, and it propagates all the way through. And so you see, instead of a shift register, this 1 gets assigned all the way through to all these flip-flops. Okay, so that'll happen with the next data point 2. So another 1 gets cycled in on clock cycle 2. A 0 gets cycled in on clock cycle 3, but it propagates all the way through. And so you see, if you use the wrong kind of equal sign, if you use the blocking equal sign in sequential circuit descriptions, you get the wrong answers. That's the point.